Hello everyone, welcome to my channel. In today's video, we are going to see about the fundamentals of matrix theory. Matrix is very useful in solving linear equations, which arise as a mathematical model of any real-world problem. Mathematicians like Gauss, Jordan, Cayley, Hamilton, these they have developed theory of matrices in order to solve set of linear equations. What is a matrix? A rectangular array of mn numbers arranged in m rows and n columns. These are denoted within the bracket, square bracket or either a square bracket or open bracket. We call this as a m by n matrix. The general form is like this. We are denoting m rows and n number of columns. Here I have given an example which contains 2 rows and 3 columns. These are the elements. This is A11, this is 5 is A12, 6 is A13. Second one A21 and then second row and then second column, second row and third column. A square matrix. What is a square matrix? A matrix A which is an m by n matrix. This is called a square if number of rows is equal to number of columns. Now, what do we mean by diagonal matrix? Here you take a square matrix where the diagonal elements are non-zero elements, and apart from the diagonal elements, other elements are 0. So this we call it as a diagonal matrix. Now consider 2, 3. This is the diagonal elements. 2, 3 are the diagonal elements, and then other elements are 0. Unit or identity matrix. Here I is said to be, usually we denote it by I. This is a unit matrix if all the diagonal elements, this you call it as a principal diagonal, 1, 1, 1. These are all the diagonal elements which are 1. Other elements are 0. This you call it as a unit matrix. Here this is, for example, if you take 3 by 3 matrix, A11, A22, A33 is a diagonal elements which you call it as a principal diagonal or main diagonal elements. Here a square matrix is said to be non-singular matrix if its determinant is not equal to 0. If you find a determinant of a matrix, if it is not equal to 0, then you call this as a non-singular matrix. Otherwise you call it as a singular matrix. And then a matrix B is said to be inverse of A provided the product AB equal to BA equal to I. In the forthcoming slide, I am going to explain how to find an inverse of a matrix. For that, to define an inverse of a matrix, we need what is the meaning of adjoint of a matrix, cofactor of a matrix, so on. So, now I am leaving as such, and then in the forthcoming slide, I am going to explain what is the inverse of a matrix. So, AB equal to BA equal to I, where I is a unit matrix, then B is said to be a inverse of A, and then usually we denote B inverse of A is A inverse. Row matrix. A matrix having only one row and any number of columns, we call it as a row matrix. Example, here I have taken only one row, that is 3 minus 1 minus 2, 4. That is, we have only one row and 4 columns. Next, column matrix, that is, which is having only one column and any number of rows. Here I have given an example which contains 3 rows and only one column. That is, a matrix contains 3, 2, 1. This is a column matrix. Next one is a null matrix. A null matrix contains all elements equal to 0. That is 0, 0, 0, 0, so on. Next definition is upper triangular matrix. A square matrix in which all the elements below the main diagonal are 0 is called an upper triangular matrix. That is, A is an upper triangular matrix if each element Aij equal to 0 provided I is greater than j. That is, below the main diagonal the entries are 0 and above the main diagonals the elements are non-zero elements. Similarly, we can define lower triangular matrix. A square matrix in which all the elements above the principal diagonal are 0 is called a lower triangular matrix. That means any matrix A is said to be lower triangular provided Aij equal to 0 for I less than j. That is, above the main diagonal the values are 0 and below the main diagonal there is a non-zero values. Next definition is a triangular matrix. A matrix is said to be triangular if it is either an upper triangular matrix or lower triangular matrix. Next one, we define about operations on matrices. Here first one is equality of matrix. In order to define equality of matrix, we take A and B any two matrices of same order, and then each element, ijth element of A is equal to corresponding ijth element of B. Then in that case we say A and B are equal. Here I have taken an example where in this case each element, that is ijth element A11 is same as B11, A12 is same as B12, A21 equal to 5, that is same as B21 which is 5. Similarly, A22 that is 7 is same as B22 that is 7. Next one, addition, subtraction and multiplication, or we call it as product of matrices. Here A you consider as Aij which is a n by n matrix, and B which contains Bij is an n by n matrix and which is of same order. Then we talk about addition as A plus B which contains the elements Cij, where Cij can be obtained as adding the elements of the corresponding ijth element of A plus ijth element of B. Similarly, we can talk about subtraction, that is A minus B, which gives an element Cij, where Cij is defined as ijth element of A and ijth element of B. For example, here I am taking A equal to a square matrix. Similarly, B equal to any square matrix. Here A contains 3, 4, 5, 7. B contains 4 minus 1, 2, 5. How I am adding? The first element of A can be added with first element of B. That is, first row, first column can be, first row, first column of A can be added with first row, first column of B. Similarly, other elements can be added. That is, 3 plus 4 equal to 7 and 4 plus minus 1 equal to 3, 5 plus 2 equal to 7 and 7 plus 5 equal to 12. Similarly, we can find the subtraction of A and B, that is A minus B, which gives the answer. Next one, product of any two matrices. How we are going to define? Here the constraint is, in order to define the product of any two matrices, the number of columns in the first matrix is equal to number of rows in the second matrix B. That is, AB can be defined means the number of columns of A is same as number of rows of B. Then only we can define the product, which can be defined as Cij, that is sum of k equal to, that is sum runs from k equal to 1 to p, aik into pkj, where our I is 1 to n and j runs from 1 to m. Now I take an example which contains 2 rows and 3 columns, and B which contains 3 rows and 2 columns. Now how we can find the product AB? Now first row of A is multiplied with first row, first column of B, that is 1 into 2, and then I have to add with first row second column of A and second row and first column of B, that is 2 into 1, and then I have to again add this with first row third column of A into third row first column of B, that is 3 into 3. That gives the first element of AB, that is 1 into 2 plus 2 into 1 plus 3 into 3 equal to 30. That is the first row first column of AB. Similarly, we find first row second column of AB, that is 1 into 3 plus 2 into 2 plus 3 into 4, which gives the answer as 19. Next we have to find the second row first column of the product AB, that is 5 into 2 plus 3 into 1 plus 2 into 3. That gives the answer as 19. Next one, second row second column of AB is 5 into 3 plus 3 into 2 plus 2 into 4. That gives the answer as 29. That's how we have to find the product of any two matrices. Next concept is a scalar matrix. Now you consider any matrix and you consider any scalar k. We can define a scalar matrix as Ka, which can be multiplied with each element of A. So that is Ka is nothing but k into each element of A, Aij. Next is a transpose of a matrix. The transpose of a matrix is obtained by interchanging its rows and columns. And we are denoting the transpose of any matrix by A transpose like this. So if A is any matrix of order n by m, then correspondingly A transpose have a matrix of order m by n. Now I have given an example that is a 2 by 3 matrix, that is 2 rows and 3 columns. 1, 2, 3, that is the first row elements. 4, 5, 6 is a second row elements of A. Now I am taking the transpose. How I am interchanging it means 1, 2, 3, that is first row can be interchanged to first column like this. 1, 2, 3, that is of A transpose. 4, 5, 6, that is second row of A can be changed to second column of A transpose. 4, 5, 6. So I get an answer 1, 4, 2, 5, 3, 6 like this. Next concept is symmetric matrix. A matrix A is said to be symmetric if Aij is same as Aj, that is Aij is same as Aj for all I and j. Now I define cofactor of a matrix. Let A be a square matrix of order n Let Aij be the element in ith row and jth column. For Aij, we have to find a submatrix by deleting the ith row and jth column, which is of order n minus 1. Next, you find the determinant of that matrix, submatrix, that you call it as a minor of the element Aij. We are denoting that by Mij. The cofactor of the element Aij is nothing but minus 1 to the power I plus 1 into the minor of the element Aij, that is Mij. That is denoted by cofactor of the element Aij is denoted by capital Aij. So we find the cofactor of the whole square matrix A, which is defined as a matrix obtained by replacing each element Aij by the corresponding cofactor Aij. Then we define adjoint and inverse of a matrix. The adjoint of A is nothing but the transpose of Aij. Inverse of A is defined as 1 by determinant of A into adjoint of A. Now we have a problem which is a very simple problem. Now I consider any square matrix A which contains A, B, C, D, which is a non-singular matrix. That means determinant is not equal to 0. We find A inverse. So in order to find A inverse, we need determinant of A, that is equal to AD minus BC. Then you find adjoint of A, which is that is minus 1 to the power I plus j into Mij to the power transpose. So that is plus M11 minus M12 minus M21 plus M22, and then we have to take the transpose. That gives the answer as D minus B minus C A. So our A inverse is 1 by AD minus CB into D minus B minus C A. Thank you for watching.